Modern safety gear does more than provide physical protection. Smart helmets, gas detectors, wearable monitors, and proximity warning systems use electronic sensors to identify hazards and alert workers in real time. Although these technologies improve workplace safety, they also create electronic waste when they become damaged, outdated, or incompatible with newer systems. This presentation explains how organizations can maintain sensor-activated safety gear, extend its useful life, prepare it for retirement, and responsibly manage it at the end of its service life. Sensor-activated safety gear provides workers with an additional layer of protection. Environmental sensors can detect toxic gases, combustible gases, smoke, excessive heat, oxygen deficiencies, and other conditions that may not be immediately visible. Wearable monitors can recognize falls, impacts, unusual movement, or prolonged inactivity. Proximity systems can warn workers when they move too close to vehicles, machinery, or restricted areas. Connected devices may also send alerts to supervisors and centralized monitoring systems, allowing emergency teams to respond more quickly. However, technology should support established safety procedures rather than replace them. Training, inspections, communication, and worker awareness remain essential. Sensor-activated safety equipment may look simple from the outside, but it often contains complex electronic systems. Processors interpret information collected by environmental and movement sensors. Wireless modules transmit warnings and equipment information to supervisors or monitoring platforms. Electronic displays, speakers, lights, and vibration motors communicate alerts to workers. Rechargeable batteries provide portable power, while circuit boards connect and control the device's individual functions. Protective housing shield these components from impacts, dust, moisture, chemicals, and temperature changes. Because this equipment contains batteries, metals, wiring, circuit boards, and other electronic materials, it should not be managed like traditional safety equipment or placed in ordinary trash. Safety gear can become obsolete even when it still appears to function. Newer devices may provide more accurate sensors, stronger wireless connections, longer battery life, and better compatibility with centralized monitoring systems. Older equipment may stop receiving firmware updates, replacement parts, calibration support, or technical assistance. Rechargeable batteries also lose capacity over time. A device that cannot operate through a complete work shift may no longer meet workplace requirements. Organizations may replace older models to standardize equipment across multiple locations or prepare for new workplace hazards. Replacement decisions should consider safety performance, reliability, maintenance history, battery condition, software support, and future operational needs, not simply the availability of a newer model. Sensor-activated safety gear is designed for difficult environments, but years of regular use still affect its condition. Dust can collect around sensors, buttons, speakers, and charging ports. Moisture can enter cracked housings or damage seals and slowly corrode internal components. Extreme temperatures can affect batteries, displays, and electronic performance. Vibration from machinery, vehicles, and industrial tools may weaken connectors and mounting hardware. Drops and impacts can damage sensors or internal circuits even when the outside of the device appears normal. Charging cables, docks, and connectors also wear through repeated use. Routine inspections and maintenance records help organizations identify damage before it causes an equipment failure or places a worker at risk. Preventive maintenance is one of the best ways to protect workers while reducing unnecessary electronic waste. Before use, workers should inspect housings, straps, displays, buttons, sensors, and charging connections. Alarms, lights, vibration warnings, and display messages should be tested regularly. Equipment should be cleaned using approved methods that will not damage sensors, electronics, or protective seals. Devices that require calibration should be tested according to the manufacturer's recommendations. Battery performance must also be monitored. Overheating, swelling, unusual odors, incomplete charging, or reduced operating time may indicate a problem. Firmware updates, proper storage, and accurate maintenance records can help extend equipment life while confirming when repair or retirement becomes necessary. Sensor-activated safety gear depends on more than the wearable device itself. Charging stations, cables, power adapters, communication gateways, calibration equipment, replacement sensors, carrying cases, monitoring software, and networking hardware all support daily operation. When an organization upgrades its safety equipment, these accessories should be evaluated separately. Some chargers, gateways, cases, and calibration tools may remain compatible with newer equipment. Monitoring platforms may also contain sensor readings, warning histories, worker assignments, and maintenance information that must be preserved before a system is retired. Keeping supporting equipment labeled and organized prevents valuable accessories from being overlooked or unnecessarily discarded. It also helps organizations purchase only the replacement equipment they genuinely need. Safety equipment upgrades should begin with an accurate inventory. Organizations should record model numbers, serial numbers, assigned locations, purchase dates, maintenance history, firmware versions, battery condition, and operating status. Accessories and supporting systems should be included as well. Maintenance records can show whether equipment remains dependable or requires frequent repair. Battery testing can determine whether replacing the battery may extend the device's useful life. Communication performance and software compatibility should also be reviewed. A connection problem may come from the network or gateway rather than the wearable device. When safe and appropriate, older equipment may support controlled training or approved backup inventories. Phased replacement can also reduce disruption while preventing dependable equipment from being retired prematurely. When safety gear reaches the end of its practical service life, it should be removed from active inventory and clearly labeled. Retired devices must be stored separately so they are not accidentally returned to service. Maintenance, inspection, calibration, and assignment records should be preserved according to company policy. Connected equipment may contain worker assignments, location information, warning records, wireless credentials, or operational settings. Required information should be saved, and sensitive data should be removed before the equipment leaves the organization. Reusable chargers, cases, mounting hardware, gateways, and calibration tools should be separated. Equipment should then be sorted into functional devices, repair candidates, reusable components, damaged equipment, and fully obsolete electronics. Sensor-activated safety gear should never be placed in ordinary trash. Even a small device may contain a rechargeable battery, circuit board, processor, sensors, wiring, communication components, and recoverable metals. Improper disposal wastes these resources and may create fire or environmental risks. Licensed recyclers can direct batteries, circuit boards, displays, cables, and other electronic components toward appropriate processing streams. Organizations should provide accurate information about equipment types, quantities, condition, and battery contents. Damaged, swollen, leaking, punctured, or overheated batteries must be identified before transportation. Data handling requirements should also be discussed in advance. Equipment should be packaged safely, and available pickup, processing, and data destruction records should be retained for accountability. Employees have an important role in extending the life of electronic safety equipment. Workers should inspect their devices before use and immediately report cracks, damaged straps, weak batteries, unusual readings, or failed warning systems. Only approved chargers should be used, and equipment should be stored away from moisture, extreme heat, heavy objects, and other sources of damage. Devices should not be dropped, thrown into vehicles, or left exposed to difficult conditions unnecessarily. Training should also explain that sensors have limitations. The absence of an electronic warning does not automatically mean an area is safe. Clear check-in procedures, assigned storage areas, and designated collection points can reduce equipment loss, prevent damage, and keep retired electronics out of ordinary trash. Sensor-activated safety equipment will continue becoming more accurate, connected, and intelligent. Future systems may use artificial intelligence to analyze movement, environmental readings, equipment activity, and worker locations together. Improved sensors may recognize hazards faster, while stronger batteries and wireless connections may provide longer and more reliable operation. Helmets, vests, respirators, and wearable monitors may also combine several safety functions into one connected device. These improvements can strengthen worker protection, but faster innovation will also increase the number of older devices being retired. Organizations must maintain equipment for as long as it remains dependable, preserve reusable accessories, plan upgrades carefully, and send obsolete electronics to licensed recyclers for responsible processing. Sensor-activated safety gear protects workers throughout demanding environments. When that equipment reaches the end of its service life, it should receive the same responsible attention that it received while in use. Computer Recycling Incorporated can assist organizations with the responsible management of retired electronic equipment. Proper maintenance can extend equipment life. Strategic planning can reduce unnecessary replacement. Organized retirement procedures can preserve reusable accessories and protect stored information. Most importantly, working with licensed recyclers helps ensure obsolete electronics are handled responsibly. Protecting workers should not end when their safety equipment reaches the end of its service life. Thank you for watching.